Hi guys, my name is DJ Kalabadabu and I'm studying in 11th grade. Some of my hobbies are playing video games and reading books. I'm passionate about teaching Python because I'm very experienced in it and I love to learn it. The goal of ECDE here is to give everyone the education they deserve regardless of age, gender, race, and religion. This course specifically would cover an introduction about programming, and this video, we're going to be covering Python basics.
Hey guys, my name is Pranav and along with TJ, I'll also be teaching this Python or computing course. I'm a junior as well, and in my free time, I enjoy playing video games and hanging out with my friends. And I'm also passionate about teaching Python because I want to share the knowledge that I've learned myself to others. And as for the table of contents for today, we'll be going over hardware versus software, so basic similarities and differences, and then we'll be going over an introduction to Python in general. And then we'll be covering what variables are and how they really work. And then lastly, we'll cover functions and how they actually work.
So the first topic we're going to be covering is hardware and software.
So if you look on the screen right now, you'll see like the basic structure of hardware versus software. So the software in this scenario would be the applications such as your browsers, such as Google Chrome, and games such as whatever games you are playing at the moment. And then the operating system would also come under software. So based on what type of laptop you have, so it could be Windows, Linux, or Mac OS, or etc. And the hardware would be the hard drive and monitor. So the hard drive would be technically the storage, and the monitor would be what's actually displaying your screen. So if it's on a laptop, your laptop would be your monitor. But if you have an externally connected monitor, that would just be your monitor.
So how you execute some Python programs, like it doesn't really run directly on the operating system. It runs on something else called an interpreter or virtual machine, and it takes it and runs it for you into the commanding language of the operating system. So like Apple would run it in Swift and so on.
So adding on to what TJ said, over this course, we'll just write Python programs that are executed by the Python interpreter. So you can download one such as, I know VS Code is the one, or PyCharm or etc. You can find one online. A Python interpreter for your OS already exists. You can use the one on lab machines, install one for your laptop, or just use one remotely.
So the next topic we're going to be covering about is Python.
So using a Python interpreter, there are basically two ways to actually interact with one. And the first one is to interact with it in a program called shell. You can tell it to execute a program that is saved in a file with the .py extension, or you can also run it from an editor, as I said before, such as VS Code, PyCharm, and etc.
So a programming language is a formal notation, and it's definitely not a natural language. So like pseudocode would not be considered a programming language. Like Python, Linux, C, C++, these are all programming languages that we use on a daily basis.
So adding on to what the last slide previously stated, on the left, you can find like a procedure or algorithm, but in natural language. And on the right, you can find a similar procedure, but in actual like Python. So on the left, you can see the recipe. It would be toast and cereal, toast the bread, butter it, put some cereal in a bowl and add milk. So this would be the natural language in which that's how humans actually talk. But on the right, that would be how computers actually interpret the language. So if you want to put code it in Python, you'd say for I in range 5, print whatever I want. And this is spelling error right there. It should be PRINT. So just act as if that's the correct spelling, but that's pretty much the difference. In Python, there'd be specific syntax in which you want to code to carry out certain functions.
So general programs are a programming language that is a formal notation, and programs should be general. So like general would be like output for any combination of mass and acceleration. and specific is like is like a specific output that you're looking for. So like 2 cups of sauce would like
So just in general, Python is one of the many programming languages, and there are two widely used versions, but just for this course, we'll use Python 3. And if you want to run Python in the command line, you can just type out the command that's displayed on the slide.
so these are some kind of data types that are commonly used in Python. So it's like integers, regular numbers, floating point numbers like decimals, strings like words with quotes around them, and booleans, true or false. So like if something is that you want it to be true, it'd be true, and it'd be false. And little none is just none.
Wrong slide. Yeah, so in regards to arithmetic commands, Python is just like a calculator in which when you type in an expression, you're actually outputting a value. So it actually gives you a value just like a calculator. So you can add, subtract, multiply, and divide. And also you can do integer division, exponent, so power rule, and also modulo, which just gives you the remainder. And in regards to integer division, it basically just rounds your value up. So it'd be if it was 2.9, it'd be 2. And if it's like 2.1, it'd be 3.
So some arithmetic commands examples like 7 divided by 2 is 3.5. 7 divided by 2, but like with no remainder is 3. 7 divided by 2.0, which is like a specific decimal, is 3.0, and so on. And also, it never rounds down to a small number. It always never rounds down to the larger number. It rounds down to a smaller number.
So in regard to expression statements, it's important to know the difference because when Python evaluates an expression, it's to get an actual result. So this can be a number or another sort of value. And a statement is to perform an action as an effect, such as printing something. So like actually like typing out something on the screen. So you guys can check down the following 2 images just for future reference regarding this topic.
So variable names, like they all must start with some kind of letter, never a number or like a weird symbol. And it could after that it could be like numbers or letters or any like symbols that like are underscores. And Python identifiers are always case sensitive. So like an uppercase, if there was an uppercase in one variable and uppercase in another, they're not the same.
So this is a key concept to actually understand regarding Python. It's important to know the difference between syntax and semantics. So syntax would be basic rules and structure, and it'd be errors result when code is not well formed, while semantics would be the actual meaning. So it'll be error results when expression statement can't be evaluated or executed due to meaning. So technically you can have a correctly syntax statement, but it would have the wrong semantic if it had the wrong meaning. So if you look at an English language, you can say, oh, I flew, which is grammatically correct, but it's impossible because humans cannot actually fly. So it's important to have a syntactically correct statement and also one that follows semantic rules.
So some of the function syntax is like define, which is shortened to def, and a parameter inside that function name that you were creating can have like multiple, so you could know what numbers or bits to put inside your function after you declare it.
So this is kind of an example of how to formulate a function to solve a specific task in Python. So if we want to compute the area of a square, so in this case, a square area and also triangle area, we could define a function with the def function, function as he just stated before. And then following that, we can actually carry out our functions such as define square area equals 4 times 4, triangle area equals 0.5 times 2 times 2. And then we can return the total area, which is just basically the square area minus triangle area, as demonstrated by the image in which we're trying to find the highlighted green area. Also, if you look at the defined compute area in the top, you would see two empty parentheses. So this would be an empty parameter list, and a parameter is basically what the user inputs to the function. But in this case, no parameters are necessary. And then if you actually want to run the function, you can run it in a shell. And you have to first call the file, as you can see below, and then you actually call the function, which is just compute area. And obviously there's no parameters, so it'd be an empty argument list, and then it would compute the area.
So another problem would be like, instead of using for, you could also use a variable instead of it, and we could write that as a side in your parameter, and in the picture you're substituting it as x, but it's practically the same thing. You could put like 5, 6, 7, 8, or any number you wanted to instead of 4 as well.
So in regard to function outputs, a function will always return a value. So as this states in the image, a function does some action and returns a value. So if you want to define 3x, you can just return x times 3. And a function does some action, and by default, it also does return none. So if we were to print something in the function, it would by default return none because we're not specifying an actual return statement. So it has to return something. So it just return none. And if you look on the right, we'll cover this in the next slide, but the main difference between return and print is that return is usually for recurring functions if you want to use a function over and over again. And it usually returns a numerical value, while print is usually like a one-time thing, and it prints a statement or like text related items.
So another functions, we usually call a function, and if there's nothing in there, it just print none, or it'll give you like an error. And suppose like this example on the bottom right, if we define compute area, and we just try to add two areas at the bottom, it wouldn't really work because it's not the correct syntax, and you're not really the computer's not really sure what to do there.
Yeah, so lastly, Python also has certain built-in functions or modules. So you can import a math module, and with that you can do various math operations such as square root, logarithms, sines, cosine, trigonometric functions, etc. So that if you look in the image, you can do the square root of 2. So you can do math.square root 2 and also math.pi. And math just a predefined module of functions, also called methods, that we can use without writing the implementations. So it's just a predefined module that already has all of its information or functions saved, but so that we don't actually have to redefine it in our own program. So it's pretty handy when it comes down to it.
So in this video, we reviewed 6 concepts. We reviewed hardware and software, the basics of Python, variables, functions, function output as well. And we're gonna wrap it up now.
Yes, so the next episode will be on iteration. So this will be the 5th episode on computing, and it'll be pretty much on loop. So stay tuned for that. That should be coming out in the relative future.
Thank you for watching, and be sure to subscribe, like, and comment down below more ideas or what was good about the video. Thank you.